Hi, I'm David with Portrait Displays, and in this video, we're going to walk through the new Calman Ready XMP series Flanders Scientific monitors using Calman Studio, the C6 HDR 5000 colorimeter, and the DaVinci Resolve pattern source. I'm also excited to show you the first iteration of our new workflow design coming to Calman Studio and Calman Ultimate. This new design has been carefully crafted based on customer feedback, and we think you're going to love it. We're starting with the new Flanders Scientific workflow in 5.16.4, and over the next few releases, we'll finalize and roll out this design throughout the entire application. Let's get started. I'm going to come down to the computer and launch Calman. With Calman launched, we're going to come up here to the top left and click on Calman. Come down to Open Workflow Template, come over to the new Calman Ready category, and select Flanders Scientific. In this new workflow architecture, all of our Calman Ready partners are now going to have new Calman Ready workflows under the Calman Ready category. With the workflow now loaded, you'll notice we're on the XMP series. If we come down to calibration type and press select, you'll notice we can calibrate for SDR, HDR and PQ, or HDR and HLG. Let's get started with the SDR calibration. I'm going to select SDR, and I'm going to choose the range I want to work in. We have a couple options here. We have video or narrow, extended, or full range. I'm going to choose video range for the SDR calibration. We'll want to now confirm that the monitor OST settings match the range in Calman. So I'm going to come over to the XMP310 that we have here. I'm going to press menu, we're going to come down to color, and we're going to select range. You'll notice the range is in 64 to 940, or narrow range. I'm going to exit out by pressing menu and come back over to Calman. Here, I'm going to come down to the bottom right and press next. Here, I'm on the hardware setup page. I'm going to come over to step 1 and press find meter. Calman's going to now search for meters, and it should find the C6 HDR 5000. With our meter now connected, you'll notice we're in the factory XYZ meter profile. Now it's important that you select a meter profile that matches the display technology or model that you're trying to measure. For more information on meter profiles, click the link in the description down below to watch our meter profiling video. Because we're working on the XMP310, we've actually made a meter profile specific for this monitor. I'm going to come down to the factory XYZ profile, select it to open up the drop-down list, and find the FSI XMP310 meter profile. There it is. We'll select the meter profile and we'll move on to step 2. Today, we're using DaVinci Resolve as the pattern source connected to an Ultra Studio 4K Mini. That runs over SDI into the XMP310. For more information on using DaVinci Resolve as a pattern source with Calman, click the link in the description below to watch the DaVinci Resolve as a pattern source video. Let's come down to Calman and press Find Source. You'll notice the Find Source window is now on the screen. We're going to choose the manufacturer as DaVinci, and under the model, we'll select Resolve Pattern Generator. Then we're going to connect to the Resolve Generator 10.240.29, and we're connected to the DaVinci Resolve Pattern Generator. We're going to set the window size to 2%, and we're going to come down to Pattern Insertion and press Reset to Defaults. We've already set some great defaults for the XMP310, but you can adjust these as needed. For now, I'm going to leave them in the default and come down to the bottom right and press Next. We're now on the targets portion of our workflow. Here, we're going to want to choose the targets we want to aim for in SDR. You'll notice the color space is in Rec 709 sRGB. I'm going to leave it there. My gamma formula is at ITU BT1886, which is great, but I'm going to actually change this because I know I'm working with a QD OLED that has near perfect black. So I'm going to change this to power and set it to 2.4. We'll leave the white point at D65, and you'll notice we now have a white and black target in the workflow. Here, we can actually now set these directly in the workflow. So I'm going to leave my white point set to 100 nits because that's what I'm targeting for BT709 on a broadcast monitor. I'm going to leave the black point at 0 because I know this monitor does a near perfect black. Lastly, we have our delta E formula. I'm going to leave that at delta ITP. That's the formula we're going to use when calculating the correction tables for the display. Let's come down to the bottom right and press Next. We're now on the all-new SDR current state workflow page. Often, a display is not always in the mode you wish to calibrate. As such, a pre-calibration report would be taken in the mode you're currently in. This might not be a fair assessment of the display's true performance. This new current state page allows you to measure the state of the display before any changes were made. This allows you to compare the current state of the display, the mode you wish to calibrate before the calibration or pre-calibration, and the final result of the calibration. Let's come down to the workflow, and I'm going to press the 100 in the bottom right. This will put a pattern up on the screen so I may place my C6 HDR 5000 on the display. I'm going to remove the diffuser and align my C6 HDR 5000 with the white window. With the C6 HDR 5000 now positioned, we'll come back up to the top right of the SDR current state page and press Measure. All right, with our SDR current state validation now completed, we can take a quick look. You notice in the top left here, we're doing a gamut coverage of Rec. 709 sRGB right now of about 97.5% in XY. And you'll also notice there's a little magnifying glass where if I click on this, I can open up the chart and get a zoomed in view of what's going on my CIE diagram. I can press the X to remove, and I can do the same thing over here on the right with the color checker. Once again, looking pretty good. If we close that chart, we can see our Delta E2000 and our Delta EITP at the same time below. These are tracking fairly well. We have been doing some development on this monitor, so it's not in a perfectly calibrated state. We can see on the RGB balance chart, we're going a little bit red. Our EOTF is tracking our 2.4 target pretty nicely, and our Delta E2000 grayscale and ITP are, again, decent, but room for improvement. If we come up to the top bar here, you'll see display performance. That's going to show you your average Delta E2000 and your average Delta EITP, as well as your max Delta E2000 and Delta EITP for each category that we measured. So if we look at these saturation sweeps, we're seeing a max Delta EITP of 6.41 and a max Delta E2000 of 2.06. Come over to the color checker, we've got a max Delta EITP of 7.19 and a max Delta E2000 of 1.89. Coming further over to the grayscale, we've got a max Delta EITP of 4.01 and a max Delta E2000 of 2.27, and our candles per meter squared are at 104.09. Not bad at all. We have been doing development on this monitor. I don't expect it to be perfect in the state that it's in. I'm going to come down to the bottom right and press Next. At this stage of the workflow, we're going to want to connect to our display. Now with the Flanders Scientific display, I could have connected before I did the SDR current state because connecting to the display does not alter the state of the display. But on some displays it does. So best practice is to measure the current state, then connect to the display. Let's press Find Display. The Find Display prompt comes up, and you'll notice the manufacturer is set to Flanders Scientific and the model, the monitor XMP. If it's not set, please set that now, and then we'll want to enter our IP address. To find your IP address on the Flanders Scientific, we'll come over to the menu, we'll scroll down the system, and you'll notice the current IP. We'll take that IP address of 10.240.2.85 and press Connect. We're now connected to the XMP310 monitor, as you can see in the top right corner. We'll come over to the LUT ID, and you'll notice we have 6 LUT IDs that Calman can talk to. But we want to do a couple more things here before we're really ready to calibrate our display. You'll notice on the right we have instructions. In the monitor OSD, we're going to want to select the third-party color system. We're going to make sure the range matches that we're using in Calman, which is video mode. And we're going to want to choose the LUT ID that we want to select inside of Calman so the monitor and Calman line up. Let's come back over to the monitor and press Menu. We'll arrow up to Color, and we'll select the color system. We'll change that from Gaia to third-party. Our range is already in video 64 to 940, and we're in video range within Calman. We'll come down to the luminance mode, and we'll leave that at 100 for now. And you'll notice third-party LUT memory is set to user 3. I'm going to start with user 1 for my SDR calibration. So I'll press Enter and change this to user 1. You'll notice the user 1 through user 6 correlates to LUT ID 1 through 6 inside of Calman. Let's press Enter and then press Menu to exit the menu on the monitor. We'll come back to Calman and I'll select LUT ID 1. Now, Calman and the monitor are both in sync. Let's come down to the bottom right and press Next. We're now on the SDR pre-cal portion of the workflow. You may remember earlier we measured the current state, which happened to be in Gaia color. We're now in the third-party system, and we're in LUT ID 1, which is the one we want to calibrate. By measuring this in SDR pre-cal, we can see where LUT ID 1 is before we optimize it. Let's come back down to Calman and press Measure. Okay, our SDR pre-calibration is completed. Let's take a quick look. You notice if we come over to the RGB balance, we're tracking pretty well. I have been doing some testing with this monitor over the last few days, so I have been calibrating some of these modes. It looks like my grayscale is not too far off in this particular mode. Our EOTF is tracking to 4. Our maximum candelas per meter squared is at 101.43. But as we come over here to the left side and we start to look at the color checker and the saturation sweeps, we'll see that we're not actually tracking BT709. So we certainly certainly have some room for improvement. The other thing that's interesting on this workflow, if you haven't noticed already, is we have this include luminance error on the top. If I uncheck it, we can actually see where the chromaticity error is. All these delta E's that haven't gone down are showing me that I have a chromaticity error. If I turn the luminance error on, you'll see it barely comes up. We're tracking that EOTF pretty well, so I expect most of my error right now to be in the chromaticity. Let's come back down to the bottom right and press Next. We're now on the Reset Picture Mode page. You'll notice a few steps specific to the Flanders Scientific monitor we'll want to follow in order to get the display in the state ready for calibration. We've already done some of these throughout the workflow, but this is a great checklist to follow to make sure you're in the right state. We've already set it to the third-party LUT memory option. We've got the luminance mode set to about 100 nits, and we've got the range setting matching between Calman, the pattern source, and the monitor. But you'll notice on step 4 here that we want to confirm the RGB gain and biases are set to 0. So let's come back over to the monitor and press Menu. We'll press Enter, we'll come down, and we've got R gain, green gain, blue gain, red bias, green bias, and blue bias, all at 0, exactly where we want them. Lastly, we'll want to confirm that the hue, chroma, brightness, and contrast are all at their defaults. We'll come back over to the monitor, and we're going to press on these front buttons. We're going to press here to make sure hue's at 0, press here for chroma, press here for brightness, press here for contrast. All are set to 0, so we're right where we want to be. We're in that LUT ID 1, and now we're going to press Reset to reset the display and put it in the state we want for calibration. With the reset completed, let's come down here and press Next. We're now on the luminance portion of the workflow. Here, we're typically going to want to measure to make sure we're in the luminance range for the monitor's calibration. So I'm going to come up here to the top right and press Measure. On the Flanders Scientific, the luminance is actually going to be set with the calibration LUT. So as long as I'm targeting just a little over 100 nits, I should be okay to achieve 100 nits with my calibration. We'll notice the luminance is currently at 116.3. Plenty of range over that target 100 for the LUT to do its correction. Let's come down to the bottom right and press Next. We're now on the grayscale multi-point portion of the workflow where we'll create our 1D lookup table. Let's come up to the top and press Auto Cal. We now have the AutoCal setup window on the screen. Here, I can choose my active grayscale points from 11 all the way up to 61. Since I'm in a video range, 64 to 940 on the monitor, I'm going to choose the 21-point video from 16 to 235. You can adjust this accordingly. I'm going to leave my delta E target at 0.5 and press OK. Calman is now going to run through the process of measuring the display and creating a 1D lookup table for the FSI XMP310. Okay, our auto cal is completed and it took 8 minutes and 52 seconds with a total of 106 reads. Let's press OK and let's come down to the bottom right and press Next. We're now on the 3D LUT calibration portion of the workflow. We're going to come up to the top right and press Auto Cal. You'll notice on the left we also have some instructions. It says the matrix LUT is suggested for this calibration. So we're going to come over to the Auto Cal setup here. We're going to uncheck that Set 3D LUT Grayscale to Unity as it says in the top left. We're going to choose the calibration type as matrix LUT and we're going to press OK. Notice in the center, you're going to see the patterns come up and the readings on the chart in the middle. On the right, we're going to do a quick validation pass once the LUT has completed to ensure everything went smoothly. Okay, our LUT has completed and the validation in the top right is finished. We can see on our Delta E2000 here, we have a max error of 0.39, and on our Delta EITP, a max of 0.7. Again, we only did a quick validation pass, so let's come down to the bottom right and press Next. We're now on that verify luminance portion of the workflow. We'll come up to the top right and we'll press Measure. Here, we're going to see how close we got to that 100 luminance target. And it seems like we're right on the dot of luminance at 100. Let's come down to the bottom right and press Next. We're now on the HDR post-calibration page of the workflow. Let's come up to the top right and press Measure to get that holistic view of the post-calibration results. Okay, our SCR post-calibration report is completed. Let's have a look. If we come down to the top right, you'll notice our RGB balance is tracking really nicely across the board. We've got that EOTF tracking really well against that yellow target line. Our max candelas per meter squared is at 100.02 nits, so we're hitting that 100 nits target. So we come down to this Delta E2000, very, very tight across the board. Delta EITP tight across the board. At the top here, we'll see that that Delta E2000 average is 0.32 with a Delta EITP of 0.48. The Delta E2000 Max is 0.89 on the grayscale with a Delta EITP of 1.06. Very, very good results here on the RGB balance and EOTF tracking of the monitor. Let's come over to the left side here where we'll look at the saturation sweeps. We've got a max Delta EITP of 0.84 with a max Delta E2000 of 0.51, both excellent and under 1. Our average Delta EITP on the saturation sweeps here is 0.41 and the Delta E2000 at 0.17. Excellent. If we come over here to the top right, we can click on that magnifying glass and get a closer look at the CIE 1976 chart here. And as we can see, all of our measurement dots are right in the target squares. If we press the X, we can now come over to the color checker. We can see that color checker has a Delta EITP max of 1.04 with a Delta E2000 max of 0.65. The Delta EITP average is 0.48 and the Delta E2000 is 0.21. Excellent, excellent results. Just what you would expect from a broadcast monitor of the FSI's caliber here. If we zoom in on the color checker chart here, once again, we can see the measurement dots are in the target squares and everything is tracking really, really nicely. Let's come down to the bottom right and press Next. We're now on the calibration complete portion of the workflow. We have a couple options here. We can save and view a report, we can view a comparison of the pre and the post, or we can restart to calibrate in another mode. Let's take a quick look at that comparison just to see how that new workflow layout looks. Here you can see the comparison of the SDR pre and post calibration results. Remember, this is taken from the pre-calibration mode, not the current state. If we look at the top, we have our saturation sweeps, color checker, RGB balance, and EOTF chart. And on the bottom, we have the same thing with the post-calibration measurements. This really gives you an idea of the improvements from pre to post-calibration. Let's come down to the bottom right and press back. We're once again on that calibration complete page. Let's come to the bottom right here and press restart so we can actually walk through the HDR portion of the workflow. Let's come over to calibration type and press HDR PQ. We'll want to change the range here from video to full. I'm going to calibrate HDR in full for the purpose of this demo. So we come down here to the bottom and press full. Let's come over to the right and press next. We're now once again on the hardware setup page of the workflow. We're already connected to our meter with the proper meter profile, so I'm not going to change anything there. But on step 2, we'll want to find our source. We're already connected to the DaVinci Resolve pattern generator, but I'm going to want to make some changes. You may remember I just set Calman up to do the full range mode when we're doing HDR. Here, I'm going to want to disconnect from the Resolve pattern generator, set Resolve to full range, and then reconnect so that I'm getting a full range signal to the display. Okay, with our DaVinci Resolve pattern generator now set to full and connected back to Calman, I'm going to make sure I'm still in that window 2%, which I am right here. Our last step here is the pattern insertion. You'll notice Calman has already set pattern insertion to both time and patch-based insertion, and the defaults are already set. If you made modifications here, you can either hit the reset to defaults or leave your modifications if that's what you find best for your workflow. Let's come down to the bottom right and press next. We're now on the calibration target page of the workflow. We're currently set to color space Rec 2020, gamma formula ST2084, white point D65. We're going to leave white set to use measured and black set to use measured and leave our delta E formula at delta E ITP. If you want to target something like P3D65, you can come up here to the color space and change Rec 2020 to DCI P3. Let's come down to the bottom right and press next. Okay, we're now on the HDR PQ current state page of the workflow. As you may remember when we did SDR, this is about measuring the display in the state it's already in. For the purpose of this video, I'm going to come down to the bottom right and press next. We're now on the Display Connect page of the workflow. You'll notice I'm still connected to the display in the top right corner where it says FSI Monitor XMP, but I'm still in LUT ID 1. We've calibrated SDR BT709 in LUT ID 1, so I'm going to want to switch this to LUT ID 2 for the calibration of HDR PQ. We'll want to now match the monitor up to LUT ID 2 so Calman and the monitor are aligned. Let's come over to the monitor and let's press menu. We'll want to select color and arrow to third-party LUT memory. Select user 1 and change it to user 2. We now have the XMP aligned with slot 2, same thing we're using in Calman. Let's come down to the bottom right and press next. And now we're on the HDR PQ pre-calibration portion of the workflow. However, you may notice that the luminance is still set to 100 nits and the range on the monitor is still set to video. So let's come back over to the monitor one more time and let's press menu, come over to color, Select the range and change this to full 0 to 1023. We'll then come down to the luminance mode and set this to 1000 for HDR. Let's press menu to exit out, come back over to the Calman workflow, come up to the top right and press measure. Okay, our HDR pre-calibration is completed. Let's have a quick look. If we look at the RGB balance, we've got a little color separation here. We're tracking that EOTF fairly nicely. Now again, I have been testing with this monitor. I don't remember exactly how I calibrated LUT-ID2 here, but it seems I have done it for HDR. As we come up to the right, we have maximum delta is about 982 nits. Our grayscale has a max delta EITP of 6.3 with a delta E2000 of 1.95. So we're not doing too bad actually in terms of this monitor in this mode, but of course we can get this better and we want to get this better. If we come over to saturation sweeps, we'll see that our max error here is a 10.83. Now we are measuring P3 inside of 2020. If we blow this up, you can see we have the BT 2020 color space on the outside with the P3 targets on the inside. We're doing pretty nice here, but we do see a little bit of errors, especially on the edge. As we come over to the HDR content colors here, we blow this up. We're doing pretty well overall. Of course, our max delta EITP has a max of 9.73 and a delta E2000 max of 1.93. Let's come down to the bottom right and press next. We're now on that reset picture mode page again. We want to change it to that third-party LUT memory, set the luminance mode, which we just did, confirm the range setting, check our RGB gain and bias settings, which we've already done, and confirm the hue, chroma, brightness, and contrast ratings are set to 0. Again, all of these were set during the SDR calibration. We made a couple changes, but we didn't change that. We're in that LUT-ID2, and we're already in LUT-ID2 on the monitor, so I'm going to press reset. The monitor is now reset. We'll come down to the bottom right and press next. Here we're on that grayscale multi-point for that 1D LUT AutoCal. We're going to come up to the top right, press AutoCal. The AutoCal setup comes up on screen. You'll notice our active grayscale points are set to an 11 point for PC. I'm actually going to change this for the purpose of this demo to 21 point in PC or full levels. We'll select 21, keep that delta E target at 0.5 and press OK. Okay, our calibration is completed. It took 4 minutes and 27 seconds and a total of 82 reads. Let's press OK, and let's come down to that bottom right and press next. We're now on that 3D LUT calibration portion of the workflow again. Let's come up to the top right and press AutoCal. You'll notice on the top left we have those instructions saying set grayscale to unity and use the matrix LUT. Well, we already have the set 3D grayscale to unity unchecked as we want it, and our calibration type is set to matrix LUT. Let's press OK, and Calman will now create the 3D lookup table. Our calibration is completed, and if we look at the right again, it looks like everything came out pretty nicely. Let's come down to the bottom right and press next. We're now on the HDR transform portion of the workflow where Calman's going to take some readings and create the HDR transform for SMPTE ST284 PQ. Let's go to the top right and press AutoCal. Okay, the auto calibration process is completed. Let's come down to the bottom right and press next. We're now on the HDR PQ post-calibration portion of the workflow. Let's come up to the top right and press measure and see how our results came out. Okay, our post-calibration results have completed. Let's have a look. Our max delta EITP on the grayscale is a 5.61 with a delta E2000 of 0.71. Our average delta EITP is at a 1.47 with an average of 0.42. Looks like this error is right near black. We're at about 5. We do have a little bit of light in the room, but still an excellent result overall. That RGB balance is tracking really nicely throughout the curve, and our EOTF is tracking very close. If we come over here to the left side where we see the CIE 1976 chart, you'll notice our max delta EITP is 10.57 with our max delta E2000 of 1.06, and our average delta EITP is a 1.53 with an average of 0.28. We can blow this chart up by clicking on that magnifying glass, and once again we're seeing ourselves tracking this really nicely all the way out to the edge of the gamut where we have a little bit of error here right at the edge on the red and the blue here. If we press the X, we can come over here to the HDR content colors with a max delta EITP of 9.66. If we come down to the delta ITP chart, we will see that's here in this brown. It's color 38, and that's measuring a 9.7. But if we look at that average delta EITP, we have an average of 1.32, very, very close outside of that brown color. And our average delta E2000 is at 0.28 with a max of 0.68. Very, very good results. Let's come down to the bottom right and press next. Okay, and we're once again on that calibration complete. But let's go through one more mode. I'd love to show you the HDR HLG mode. So let's come over here and press restart. Okay, we're back on the welcome page. I'm going to come over here to calibration type, and I'm going to choose HDR HLG. And for the range, I'm actually going to select video, just for the purpose of this demo. Let's come down to the bottom right and press next. Now, once again, we're already connected to that meter with the meter profile already loaded. We're connected to our source, DaVinci Resolve. However, I'm going to disconnect from DaVinci Resolve and set that back to video range for the purpose of calibrating HLG. Okay, so I now have my DaVinci Resolve pattern source set up to video range. I've got Calman in video range, but let's come over to the monitor now and press menu and get this back into video range. We'll press menu. We'll come over here, we'll hit enter. We'll scroll to the video range. We'll change this from full to video, and we'll press menu to exit. So now we've got the pattern source, the monitor, and Calman in video range. We're going to leave our pattern insertion in the defaults. Let's come down to the bottom right and press next. We've got our targets in BT 2020, gamma formula HLG, white point D65. We'll use the measured white, we'll use measured black, and we'll stay in delta ITP, so no changes are needed here. Let's press next. We have HDR HLG current state. We're going to skip that for now. We don't need the current state. We just want to work through that calibration process. I'm already connected to my FSI monitor here on the display connect page, but I am going to change my LUT ID to 3. I don't want to overwrite both the SDR or the HDR PQ LUT, so I'm going to move from 2 to 3 and select a new LUT slot. And again, I'm going to want to come over to the Flanders Scientific monitor. I want to press menu, select color, come down to the bottom here and select third-party LUT memory and change it from user 2 to user 3. We'll press menu out and we'll come back over to Calman and press next. Okay, we're now at the HDR HLG pre-calibration page, but we've already run through this process a few times. So for the purpose of time, I'm going to skip the HDR HLG pre-calibration and press next. Once again, we're at the reset picture mode page. We want to make sure we're in that third-party LUT memory, which we are. We want to set the luminance mode setting to one that meets or exceeds our target. We're in 1000. We want to confirm that the range matches Calman in the pattern source. We did that, we're in video range. Our RGB gain and bias controls have not changed, and our hue, chroma, brightness, and contrast are still at their default of 0. We're in LUT ID 3. Let's reset that to get that in the state ready for Calman to calibrate, and let's come down to the bottom right and press next. Okay, we're now at that grayscale multi-point portion of the workflow where we create that 1D lookup table. Let's come up to the top and press AutoCal. The AutoCal setup window has now prompted us on screen. We're in active grayscale points 21, video to 16:35. Our delta E target is at 0.5. Let's come down to the right here and press OK. Okay, the grayscale calibration is completed. It took 14 minutes and 34 seconds and a total of 144 reads. Let's press OK, come down to the bottom right and press next. Okay, once again, we're on that 3D LUT calibration portion of the workflow. I'm going to press AutoCal and bring up that AutoCal setup menu. And if we look at those instructions on the left-hand side, you'll notice it says in the 3D LUT dialog box, uncheck set grayscale to unity, which it already is. It also mentions that for the HLG calibration, we want to use that lightning LUT. So let's come down here and make sure we're choosing lightning LUT, which we're already set to. We're going to leave the video range in SMPTE Plus 16 to 255, and we'll press OK. Okay, our calibration is completed. It took 12 minutes and 59 seconds and a total of 101 reads. Let's press OK and let's press next. Okay, we're on that HDR HLG post-calibration portion of the workflow. Let's come over to the top right and press measure. Okay, our post-calibration results have completed. Let's have a look. If we come over here to the grayscale, we're looking at a max delta EITP of a 1.27, max candelas per meter squared at 935.31, delta E2000 at a max 0.62. Our average delta E ITP on this grayscale is a 0.72 with an average delta E2000 of 0.27. If we look here, our GP balance is tracking really nicely, and we're tracking that EOTF target really, really nice for HLG. Coming over here to the left-hand side, looking at the saturation sweeps, our maximum delta EITP is at 7.43. If we come down here to the bottom chart here, the delta EITP, we can see that's happening on the red. If we come back up to the top, we'll see our maximum DE2000 at a max of 0.36, and our average ITP is a 1.51 with an average of 0.22. Again, we can blow that up, have a little view here. We blow this up, we can see that red is maybe just a little bit off, but not terribly. If we come up to the top, we can hit this include luminance error. If we take that off, we can see that the red doesn't really shift down here on the delta EITP chart. What that tells me is it's probably a chromaticity error that we're seeing here. So if we turn that include luminance error back on, we'll see the red doesn't really shift very much. We're seeing that as a chromaticity error. Coming over to the color checker, we have a delta EITP max of 1.95, a delta E2000 max of a 0.4, ITP average of a 1.19, and a delta E2000 average of a 0.25. Very, very good results here across the board on HLG. Blowing up that color checker chart, really, really tight. Okay, so there you have it. We've calibrated the Flanders Scientific XMP310 for SDR BT709, HDR PQ, and HDR HLG using the new Flanders Scientific workflow available in Calman Studio and Calman Ultimate. If you found this video helpful, please give it a like. And if you're new here, please consider subscribing. Thanks for watching. We'll see you on the next one.